Hello again, and welcome to our series of podcasts on SuperCloud Composer. I am your host, Kevin Culp, PM Head of Cloud Management Solutions here at Supermicro. Today, we are going to focus our discussion on how SCC integrates its lifecycle management requirements for GPU servers. Before we dive into the mechanics of GPU server integration with SCC, it is necessary to understand a few concepts. A converged GPU server can come in different models and different flavors. Accelerator manufacturers such as NVIDIA, AMD, Qualcomm, and Intel manufacture different accelerators for different workloads. Choosing the right accelerator for the right application or workload is paramount. In later videos, we will discuss in more detail how Supermicro is building its unified fabric director to support different fabric reference designs to support resource disaggregation. So really, what is the difference between a CPU and a GPU? Intel's definition of CPU is millions of transistors on a chiplet. Each core processes application data executing commands from an operating system either in kernel space or user space. Modern-day computers today have a CPU commonly referred to as the brain of the computer. The GPU is fundamentally a larger compute engine made of smaller and more specialized core. By working together, each core delivers massive compute power and performance when processing transactions in parallel. The emergence of GPUs started in the gaming industry when both Radeon ATI and NVIDIA started their entrance into the industry. GPUs began as specialized ASICs to support both 3D rendering and gaming applications. Today, AI, generative AI, deep learning, and machine learning now have taken center stage, thus exploding the demand for GPU servers. Supermicro continues to lead the market in high-performance compute, where its GPU servers are in huge demand. Thomas Henson, who is a YouTube blogger, does a pretty good job of explaining both inferencing and training. He breaks down the differences simplistically as a test dev environment and a production environment. So training is your test dev environment and inference is your production environment. So what is the real difference between inferencing and training? For training environments where we want to train an untrained data model, a neural network is typically utilized. Data scientists often use applications such as TensorFlow or Cohen's Kappa to train their model. Perhaps a real live example would be to train a dataset model that can distinguish between male or female. Once the data scientist is satisfied their model was successfully trained, the inference can now be loaded into a camera so it can perform facial recognition to distinguish between perhaps a male or a female. Supermicro offers a broad portfolio of GPU servers to support both HPC, ML, DL, and AI. In the next video, we will look deeper into how SCC performs lifecycle management, GPU performance metric collection, and rack level management for a GPU cluster, SuperPod, or AI factory.